Good morning, students, and welcome back to our classes. We still continue our efforts in bringing statistics to your doorstep. Today, we want to look at probability distribution for the toss of three fake coins. That is, when three fake coins are tossed up together, what is the probability distribution of such a trial? So, we first of all begin by determining the sample space of the toss of a three fake coins. And to determine the sample space of a three fake coins, first of all, we need to determine how many elements that ought to be in that sample space. Then we're considering a coin has two faces, and then we have three coins that we are going to toss up together. So for us to determine the number of items or elements that are going to be in the sample space, we are going to use a known formula. That known formula is given as 2 raised to power what n, where this 2 stands for the number of the faces of the item, and in this context, we are discussing a coin, and a coin has two faces. And this n here stands for the number of coins that are tossed up together, or the number of trials that a particular coin is repeated. So we are looking at three coins, so our n here is what is 3. So if n becomes 3 in 3 coins, we are going to have what? 2 raised to power 3. And 2 raised to power 3 will give us what? 8. So the sample space we are going to determine is going to contain 8 members or 8 elements. How are we going to do this? We come back here. We are looking at 3 coins. We are looking at 3 coins. We said that the formula we are going to use is 2 raised to power what? N, where n stands for the number of the coin, and we are looking at 3 coins. So we have 2 raised to power 3, which gives us what? 8. So we want to go and determine the sample space. And of course, you know that it is possible that when you throw 3 coins up, it is possible that you are going to have heads across the board. So in that case, you are going to have 3 heads. And we are going to represent it with what? With 3 H. Where this H stands for what? For head. It is also possible that when you throw it up now, you have 2 heads and a tail. So in that case, you are going to have what we call the 2 heads, comma, T. Then it is also possible that when you throw it up now, you are going to have only 1 head and 2 tails. And it is possible that you throw it up now and you have 3 tails. I will repeat. It is possible that when you throw the 3 coins up, in the 3 coins, you are going to have head in all of them. Because you have just thrown up 3 heads, 3 coins, it means that you are going to have 3 heads. It's also possible that when you throw the 3 coins up, you happen to have heads in 2 of them, and then the remaining one is going to be a tail. In that case, you have 2 heads and what? A tail. It's also possible that you throw the 3 coins up together, you obtain only but a head in one of the coins, and then the remaining 2 coins, you are going to have 2 tails. It stands for head and 2 tails. It's also possible that you throw the 3 coins up, and in 3 of them, you are going to have tails across the board. So this is the representation. So how are we going to show the distribution now? Where we have these 3 heads, of course, we are going to have head, we have head, and we have what? Head. These are the 3 possibilities we are going to have here. Then under these 2 heads and a tail, we can have it this way. We have head, head, and tail, where the tail came last. Tail equally can start with what? The outcomes. And then you have what we call tail, head, and head. It is also possible that the tail happens to be at the center, and here you have what? Head, you have tail, and you have what? Head. So these are the 3 possibilities you can have under 2 heads and what? And a tail. Then we move over now to a head and 2 tails. Here we have what? Head, tail, and tail, where the 2 tails come last. It's also possible that the 2 tails will begin the outcomes, and you have it what to be what? Tail, and head. It's also possible that you happen to have a tail in the first coin, the second one you have the head, and then the last one you have the tail. And you have tail, head, and then tail. These are equally the three possibilities you can have under this caption: a head and two tails. Then coming over here, you have tail, and you have tail. So we are now going to use a set to collect all these possible outcomes. Once we do that, we call it the sample space of the toss of a three coins. And then let us represent the sample space with a capital letter S. And in that case, I have S is given as a set containing, the first one I have here is what? Head, 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 comma. We come over here, we have what? Head, head, we have what? Head, and then tail. Then we are here now. We have tail, head, comma. We are here now. We have head, tail, and then head. Here we are now. We have what we call the head, tail. Here we have tail, and head. Here we have what? Tail, head, and tail. And then the last one we have tail, and tail. So this is what we call the sample space of the toss of three coins, which of course is a set that contains all the possible outcomes that one can have when one throws three coins up together, or when one tries the toss of a coin for three good times. These are the possible outcomes. Because our interest is to obtain the distribution of the toss of the three fake coins, we are going to talk about what we call the range space. And when we want to determine the range space, look at what we are going to do. Let us represent the range space with what? Capital R subscript X. And then in this case, I have what? R subscript X. Our interest now is to know the number of heads that we are going to have from this sample space. Then it is going to be this is equal, we have this. How many heads do I have in the first trial here? I have head. They are three in number, so I'll write 3, comma. How many heads are this place? I have what? 2, because it is only 2. How many heads are equally here? I have what? 2. How many heads are equally here? I have 2. How many heads are here? I have 1. How many hairs are here? I have 1. How many hairs are here? I have 1. And how many hairs are here? I have 0 there, because there is no head there. Now we can call this thing the range space. But you do remember the principle in a set, that in a set, no element or member of the set is allowed to repeat itself. And going by this range space, of course, you are seeing 2 repeated 3 times. You are seeing 1 repeated 3 times. So we are going to let go of the numbers that are repeated more than once and keep those ones that is just appearing once. Once we come to this one that is repeated more than once, we pick only 1. So our range space now is going to be R subscript S is going to be, here I have my 3, here I have my 2, here I have my 1, and here I have my 0. Looking at this set now, no element is repeated more than once. And in that case, we are free to call this what we call the range space. Because all these members now, they occur only but once. So I'm going to use this range space now to prepare the probability distribution of a toss of a 3 fake coins. So you permit me to dust here or to clean up here, while we now use this range space now to be able to obtain our probability distribution. When we talk about probability distribution, our interest is in considering the number of the times that an outcome occurred in a trial, and then the corresponding probability of the occurrence of that particular item. So let me clean up here, and then we use this to show it. So you permit me to clean here. And let me clear something here so that you will not be confused when you see something like this somewhere. This range space can equally be written this way. In my own case, I began with 3 here and ended at 0. Someone else, because of course you know in a set, the position of the members of the set does not change the meaning of that set. So some other person can write it this way, that R of X is given as 0, 1, 2, 3. We are still saying the same thing. Here we are saying 3 heads. Here the person is saying beginning with where you have a 0 head. So in that probability distribution, I am going to have this, I have this, I have this, and I have this. Okay? So I have this, where here I am talking about what the random variable. And then let me call this my random variable x, where this my random variable x is talking about the number of heads that occur when I threw 3 fake coins up. Of course, there is a place where I can have 0 head. So here becomes what? 0. Here becomes 1. Here becomes 2. And here becomes 3. So I'm going to talk about P of what? Of x. What I call P of x is probability of 0 head occurring will be here. Probability of 1 head occurring will be here. Probability of 2 heads occurring will be here. And probability of 3 heads occurring will be here. So we are going to determine these probabilities now using this as sample space here. The first one is talking about what? Probability of a 0 head. And of course you know that the primary definition of a probability is expected outcome all over total possible outcome. So if I come here, I will talk about my probability is given as expected outcome all over total possible outcome. Expected outcome. Permit me to write it as O all over total possible outcome. Permit me to write it that way. So here our interest is on 0 head. So my expected here is that a particular outcome when I toss 3 fake coins up and I happen not to have a head there. Then we come to this sample space and we check it. We move down. It is only one place where I have TT up to 3 places where there is no head. So in that case, my probability here, P, is going to be 1, which is this single place where there is no head. For total possible outcomes means everything that occurred. And of course, they are 8 in number. 1, 2, 3, 4, 5, 6, 7, 8. So it is 1 all over 8. So I will come here and write what? 1 all over 8. Then we come over here. When we come over here, our interest is getting the probability where we are only going to have 1 head. If you come here, we have 1 head here. If you come here, we have 1 head here. If you come here, we have 1 head here. So we are going to count the outcomes where we have only one head. Here is 1, 2, 3. So my probability here, P, is going to be 3 all over 8. So I will come here and write 3 all over what? 8. Then I will come over here. Our interest becomes where we are only going to have what? 2 heads. Here I have 2 heads. Here I have 2 heads. Here I have 2 heads. They are equally 3 in number. That gives me 3 over 8. So I happen to have 3 all over 8. Then I come to a place now where I am going to have 3 heads. Then we come here. Here we don't have 3 heads. We don't have 3 heads. We don't have 3 heads. We don't have 3 heads across the line till I arrive here. How many are they in number? Only 1. So I happen to have what? 1 all over 8. And to tell you that you have arrived at the answer correctly, the sum of all the probabilities must have to give us 1. So when you sum all these probabilities and the answer isn't 1, it tells you or it signals to you that your answer is wrong. So let us now confirm before we can categorically say that this is our probability distribution. To sum all the probabilities now to know whether it is going to give us 1. Let us try it. Here becomes 1 all over what? 8 plus what? 3 all over 8 plus 3 all over 8 plus 1 all over 8. This is equals. The LCM of 8, 8, 8, and 8 is of course 8. We now say this is 8. 8 divided by 8 is 1, multiplied by 1 is what? 1 plus. 8 divided by 8, 1, multiplied by 3 is 3 plus. 8 divided by 8 is what? 1, multiplied by 3 is 3 plus. 8 divided by 8 is 1, multiplied by 1 is what? 1. Let us come to the numerator. 1 plus 3 is what? 4. 4 plus 3 is 7. 7 plus 1 is 8. And this will give me 8 all over 8. And 8 over 8 will give me what? 1. Because 8 divided by 8 is 1. For the fact that I've arrived at the sum being 1, I can go ahead to say that this is the probability distribution of the toss of a 3 fair coins. Therefore, each time you are asked to prepare the probability distribution of a toss of 3 fair coins, when the interest is in determining the number of what of heads appearing in each of what of the outcome, this is what we are expected to do. There could be a question that might be paying attention to you determining the probability distribution when the interest is on the number of days that is going to occur. That should come up in our next class. So each time you are told to do this, this is what we are expected to do. And still remember to subscribe to our YouTube channels, follow our discussions, like and share our videos as you are going to gain from such. Thank you for being our audience for today.